a big welcome from my side also, and I'm really happy to take this webinar on testable code on behalf of Zend. And yeah, I've prepared lots of slides. As you can see on the bottom right of the screen, there are 46 slides waiting for us. So it will be quite a tough session, and I hope you are all still really concentrated and things so that you can easily follow. Okay, first of all, a little bit about me. You already know my name. My name is Toby, if you forgot it. I got a degree in computer science. I'm in professional PHP projects since 2000, so this is 12 years by now, which is incredible. However, I'm also pretty enthusiastic on open source projects, and I'm involved in various of these free and open source projects out there. And yeah, I hope you all love open source as much as I do. A little side note on my company: I'm also one of the co-founders of a company called Kwafu. We exist since 2 years now, and what we do is we help people to create high-quality web applications. You see the URL there, so you can find plenty of information about us. But I still want to give you a little bit more on what that means, creating high-quality web applications. What we do is expert consulting and individual training. We are a bunch of experts from the PHP community, actually, and that includes stuff like software architecture, for example, REST web services, audits, discussion partners. We do quality assurance, continuous integration, help you to do testing, automation, and also software design like solid principles, review of your design, specification discussions, and all that stuff. Good. That was the simple marketing block from my side. If you want to know more about that, please don't hesitate to contact me later on. By the way, we also now do JavaScript. Since 1 month, we also got one of the JavaScript experts on site, so we can provide you with a full stack of stuff. Good. What are we going to see? First of all, I have some introductional slides on testing in general and testing in the PHP world. After that, we will dig into 4 of the most common issues when writing code and testing it afterwards, or in the TDD way, right before writing the code. Then we will come to a conclusion, and there is, of course, also the Q&A part, which is then organized by Lydia again. So if we talk about testing, there are really many ways in which we can classify the way we test our software. Of course, the first distinguishing is if you do automated testing, like just hitting a button and your software will be automatically tested, or if you do manual testing, like somebody is watching your code, or if somebody is running your application and trying to break it or seeing if it actually works. You can distinguish between tests which you write on your own or a dedicated tester executes for you. We have internal tests, like the ones which are done in our company, in our team, or external tests, which are executed by somebody from the external side, like a customer or somebody else. You can, of course, distinguish between back-end and front-end, like PHP or JavaScript in the front or whatever you have. You can test your code or also the appearance of your application. Is it visually correct? You can assert functional tests, like unit testing. Does it work correctly as I desire it to work? Or non-functional aspects of your application, like is the performance as I desire it? Can I handle as many users? And all these things. And you can also distinguish between dynamic and static testing, where dynamic testing is the execution of code actually, and static testing is asserting metrics on the code, for example. So in our webinar today, we only deal with the left side. That means we are concentrating on automatic tests, which are created by a developer, which are executed internally in the project, which are happening on the back end, at the PHP side, which are asserting something on our code, functionality to be specific, and these are dynamic tests. They actually execute something. In this area, we basically have 5 basic types of tests which are most common in the PHP world. This is, of course, the famous unit testing, which most people nowadays do in the PHP world. We also have integration tests, so these tests do not only test a single unit of code, but test how many units of code integrate with each other. If we go on a top level of our application, like executing the complete application stack, including the underlying system, the database, and all that stuff, one commonly states that an integration test is a system test. What is really important in testing, and what really many people do, is regression testing. What that means is that you find a bug in your software, you then write a test case to reproduce that bug first, you then fix the bug, and the test case helps you to avoid that this issue occurs once and again in the future, which really, really annoys customers. And I can really tell you a story about such stuff in projects. The final thing which most people have to do in their project is acceptance testing, like having the customer looking over the website, the application, trying it out, seeing if it fulfills all the requirements which have been defined. But this can also be handled in a somewhat automated way. For example, you can have Selenium or a similar tool and assert that certain dialogues appear if you issue something on your application. So for these task methods, especially for the unit and integration tests, we need to code in a certain way so that it is easy for us to create tests. And that is what we will be talking about in like a few minutes. Before looking into how to write testable code, it is important to make clear what the requirements of tests commonly are. It is really important for test cases that they are really, really easy to read. There are some statistics out there which claim that source code is read 10 times more often than it's actually written. Like, you typically write source code once, then you maybe fix some bugs, you maybe refactor it, but in between there are so many eyes running over your code trying to understand what your code actually does, and that should be way more important to us when crafting sources than that it's really, really simple and fast to write the code. So readable code is way more important. Of course, your test suite should be reliable. It doesn't give you anything if you execute your tests and you have everywhere just like assertions, true is true, and you say, oh, cool, my test suite ran successfully, and then the application breaks and the customer is annoyed. That is not a good thing. So we want to craft tests which are reliable and which can give you an assertion on the quality of your project. Of course, what everybody desires is having 100% code coverage. That doesn't tell you anything, but however, what people actually desire is to have extensive tests, to have every single part of their software tested. And then if you once wrote the tests, you want to behave them to behave stable. Of course, nobody wants to throw away the whole test suite after a single refactoring and then dig into all the tests again and write them all from scratch. That is not a good thing. Another thing which is really important to many people, which is not listed on the slide here, is, of course, the performance of your test suite. So a unit test suite, for example, does not give you anything. If it runs like 20 minutes or 30 minutes, nobody will actually run them on their development machine again. And what you, of course, desire is that your unit test suite is run before any of the commits that go into your source code repository. That is a really interesting situation for me, by the way, because I have no feedback if somebody understands what I'm saying. So I hope that Lydia is taking good care for you, but I'm pretty sure she will. If we look into these kinds of tests, which we had on the 2 slides ago, I think, then an important thing which you need to consider about these tests is how stable these tests will be in the run of your project and what kind of coverage they can give you. So, as I said, code coverage is important to most people, but you can easily gain code coverage of like 70% by just executing some automated Selenium tests on your application, testing the most common use cases, and you got pretty high code coverage. However, whenever you change anything in the backend, like displaying a button somewhere else or changing the way the button is displayed on the front page, you can basically throw that test away and create it from scratch, which makes it pretty much unstable. On the other hand, in this graph, you see at the bottom here that unit tests are quite stable because, yeah, normally you craft a class in some way and then you write unit tests for it, or even better, you write unit tests up front. But then you are pretty sure, okay, this class can stay as it is, and the likelihood that changes occur on that class, for example, in your infrastructure code, is very, very low, that this test must change in the future. It will, of course, give you only a very low coverage, but yeah, in the end, it gives you a more stable test suite. What most people really don't consider nowadays, because unit tests are so hip, is that you need a good mixture of these tests. For example, in a project which is really, really agile and really works together with the customer with no big requirements document up front, a mixture of unit tests for only the infrastructure components and only the really important classes, and then putting functional tests or acceptance tests on top, which may be also created by the customer, is a way better mixture than just going for everything unit tested. Okay, so that first up front, which you need to consider in order to write proper tests for your project, and that is why I consider this stuff so important, to think about the good test mixture and what you expect from your tests, actually, before you think about the code which you need to test and writing the test cases themselves. Let's dig into some code. I'm a big fan of digging into code and showing stuff in code, so I hope you all are also fans of code and don't expect me to show UML diagrams, for example. But from my experience, most PHP people are not interested in UML diagrams anyway, but want to see code, so I hope you all like this way of presenting. I've actually prepared an example which we commonly use as a basis in our trainings. And this example realizes a little module, a little component, which is called a weather loader. And this weather loader should be used in order to fetch weather data for a certain location from some web service provider, and it should also provide some logging and stuff, and should return a nice crafted class, a nice crafted object, which represents the current weather condition at this location. So this is our first weather loader thingy. It is pretty simple class with quite some code, but let's just dig into that and look what issues are in that class. First of all, we have this method getWeatherForLocation. It receives some kind of struct, and this struct is a location which represents whatever, a city or something like that. And as it retrieves that struct, it goes into some deeply nested methods and performs some data fetching, some logging, some parsing and things. And we will look into that code and see where the issues in that code are, and hopefully we'll then see how to craft code for that it gets easier testable for us. As you can see, I've prepared 4 of the most common issues. So issue 1 is directly visible in that example. So let's open that again. As you can see here, there are some protected methods in the class which are called by the public method in order to dispatch certain parts of the execution. So first of all, we have that fetch data method here, which receives the name of the city, and what it does is it's creating a URL, and then it calls another protected method which is capable of fetching data from that URL, like for that specific city. Then we have a static call to a logger, which we will look into later on. And after that, another protected method is called, which is called parseData. It retrieves the XML data, which we retrieved from whatever service we are calling. And what it does is, creating, of course, a weather struct representing the weather, and dispatching again to some protected methods, which are handling the details, like parsing the weather conditions, parsing the wind speed, converting the miles which are returned in the wind speed to kilometers, and also on. As you see, there are lots of more protected methods in here, which I've skipped using these dots, otherwise the slide would have been really unreadable. And that is the first issue which we have in our code. So what people typically desire in that situation is to have a way of testing the protected methods in their class. Right? If you look into that at the first glance, you would say, oh, that is cool. I can, somehow test that thing. I can write a unit test for the getWeatherForLocation method. But, of course, there's this nicely fetch data thingy, which I can test dedicatedly. There's this parseData method, which I can also test dedicatedly if it would only be public. So what most people do is then just change the protected thing to public, and yeah, as you can see here, this change was really, really small. The protected keyword here just changed to public. And then it's really easy to write tests for it. So you can dedicatedly test the parse data thingy and the fetch data thingy, and then you can also write some more tests for the get weather for location method, and everything is fine. But in the end, most of you might have guessed that there is a big no-no. Don't do that. The big issue there is if you once made something publicly available in a class, people will definitely sooner or later start using that thing without using the real method which is made for public usage. And that can easily break your application if you just want to refactor something internally in the class. This is why you made that stuff protected or even private. And then people rely on that functionality. So it's a big no-no to just make stuff public which has been marked protected or private beforehand. So what we can do instead is, yeah, for testing purposes, just create a dedicated mock class which extends our weather loader class and then overrides the protected methods, make them public, and then just call the parent. So this is, yeah, of course, a way better way of handling that stuff instead of just making it public in the productive code. Because then you do not have the issue that people intentionally start to call these originally private or protected methods by themselves and making use of them. However, what you still have, if you react like that, is that you lose the possibility of refactoring your class internally without affecting external code. Because, yeah, now your external code, the test code, relies on these methods and on them not to be changed in the future. You cannot easily say, okay, fetch data now gets the GPS coords instead of the city, which would be perfectly fine if you do that in a private method, but it's not possible anymore if you have dedicated tests for these private methods. Therefore, it will break your test whenever you refactor something which is hidden in your class, which is by intention hidden in your class, and which should not be called by external code. So this is also a big, big no-no in order to make that stuff testable. As a summary, what should be avoided in order to make code testable is, of course, to expose functionality to the outside which is meant to be private, because it will be used. It creates actually a public API, so it's really hard to change either way if you make it public in the production code or if you override it in the tests. And internal dependencies might actually break if you then, after having that stuff public, start to refactor your internal code. So, what is the issue here? The issue is, in the end, that our original class, the weather loader, has way too many responsibilities. If you remember the code, that stuff got the location struct, it then created the URL and fetched data from there. After that, it started parsing this data and also dispatched internally some of the parsing stuff. So it has way too many responsibilities for a simple class which should be easy to test. How could you solve that? The answer is so simple. Think about which responsibilities you have for a certain module, and then split up these responsibilities into dedicated classes, into dedicated abstractions, which are then bound together maybe by a dedicated class which can be called from the outside. So what the weather loader in our example for a weather loading module actually is the public API which should be exposed to our application, which is actually meant to be used by people working in the application, by people hacking on the application. So what I did here is splitting up the responsibilities of the weather loader into a weather service, which is of course then responsible to fetch the actual weather data, and into a weather parser, which fits to the weather service and knows how to parse the data returned by the service. If we did that, of course, the stuff is stored in the class here. I skipped that to keep the example as slim as possible. If we have that, then our getWeatherForLocation method is essentially dispatching to these classes. First of all, the service is called ask, give me some weather for the location I got here. The data is stored in some local variable, and then the parser is called and asks, okay, please parse this data into a weather struct, and I will just return it. The weather loader's own responsibility is now only to glue some other classes together, which have dedicated responsibilities. Okay, it also does some logging, but then it's really, really slim, really, really straightforward. And as you see, of course, this method is now way easier to test. You now need maybe 2 mock objects or stub implementations of the weather service and the weather parser, and then you can simply run a single test case which executes correctly, and maybe 2 or 3 more test cases to deal with error conditions to check that everything works fine in the error case. A nice thing which we got now in addition is that we can easily replace in our weather loader which types of weather services are used. For example, if you use the hack by now and ask the Google Weather API, which actually exists, but is only for internal use in the iGoogle portal, if you use that by now in order to grab your weather data, and Google tomorrow says, oh, we are closing that down, or we are changing it, or we want to have money for that now, then you can simply replace the functionality by implementing another class which extends the weather service abstract-based class, or implements the weather service interface, and provide an additional weather parser for that, and then you are pretty much done with exchanging that stuff without messing around in your whole application. Before that, you would have to completely rewrite the weather loader and implement its interface again. So we might have spared some time in the future. In summary, I can only say never attempt to test private or protected method. Always do that implicitly by testing the public interface. And that is not, if that is not possible, then you should actually change the code. I know that is not really easy in legacy projects. Like in legacy projects, you would first have to write a dedicated test suite to test that the functionality which is exposed to the outside still stays the same, like an integration test, for example. But then you should really think about refactoring such essential modules and try to test them implicitly, try to test the private and protected methods implicitly. What that, of course, results in that private and protected methods are really getting rare in your project. The only real use case for them is that you have some common code which is used in the class by multiple methods, and because you don't want to have code duplication, you take these 2 or 3 lines of code and put them in a private or protected method. But these can still be tested inherently by thinking of them as if they are inlined into the code which is publicly exposed, and then test these publicly exposed code. Okay, so that was the first issue which could be fixed in our code. Of course, what I've now shown is some way of refactoring, which also applies to you if you have legacy code lying around and want to refactor that. But on the other hand, it should give you an impression on how to craft code from scratch that is easily testable, and that is one really important thing, that you think about the responsibilities and put one dedicated class into each responsibility, in charge of each responsibility, so that they are not have a huge mass of code in one class and then need to execute tests on that. Okay, I hope everybody's still with me and everybody's fine. Please don't hesitate to tweet on that webinar. I hope it's interesting for you, and I hope that you tweet that. But also, if you have critics on the webinar, please feel free to issue that on Twitter. I will, of course, answer on that later on. Let's have a look into the second issue in our code. The second issue, you might have guessed it, is the statical call to the log debug function or log debug method on our logger class. That is a really bad thing, because if you want to write a test for the getMethodForLocation method, you cannot replace that logger class in the backend. You cannot simply say, okay, I'm putting a mock object there which does nothing. You cannot say, I want to assert that the logging actually takes place, because there is a static call to the logger, and the logger will be called no regards of what happens in the test. That, of course, can also make your tests really, really, really slow, Because if you have a file system logger, for example, then it will always write to the file system whenever you execute some tests on the getWeatherForLocation method. And since these logger thingies are really, really common in most applications, your test suite will get really slow by the disk I/O produced by the logger. Additionally, we might run into the case that the logger is whatever, misfunctional or something like that because it has already been called by other tests in our test suite, and then our tests are not independent anymore. And that is one thing which you should always keep in mind, that each test method, each test case is as independent as possible from each of the other tests. And that, does not really work if you have a static call to your logger here, because all the tests will log into the same log file. You will need to take care of whatever stuff to clean up the log between test cases to make tests as independent as possible. Of course, there are ways to work around that. For example, in your logger class, which is roughly displayed here, you see, still remember the log debug method here, you can, of course, put a public method into that, which you can call, which resets the log for testing for you. But you might already have guessed it from the last issue, putting public methods into public interfaces is not a really good idea, because that will definitely be used sooner or later in your project. And there will always be a case where somebody thinks, oh yeah, nice, we have this reset for testing thingy which cleans up our log file, and for example does that in a catch statement for an exception and thinks, yeah, if I catch that exception, everything is fine, I can throw away everything from my log, so I can use this reset for testing method, it is already there, it does what I want, I will just call it. And that can definitely run into really, really debugging hells for you if you wonder, what the fuck, why is my log gone there after catching that exception? So putting another public method in your productive code just for the purpose of realizing a test for your code is not a really good idea. Another incarnation of this issue, which is really, really common in projects which use singletons, and I can promise you there is a huge lot of projects out there which use lots of singletons, is use it like that. You have this class logger, you have this getInstance method, which is called over your code. So in order to put a mock or stub object into that singleton instance, you get this setInstance method, and you can put in a logger stub or something like that there. Again, I can only tell you, I have seen so many weird projects. People start replacing the logger in the middle of the code, like, oh, now we are doing something in the database which takes a long, long time. We don't want to have that logged all over the code, so we just inject some memory logger and dump it later on. Or people start replacing whatever loggers in there which they might think which can easily break your application. So this is also a big, big no-no. In the end, please, singletons are a big, big, big no-no. You should really try to get rid of all your singletons in your code as soon as possible, because singletons generally only harm your code sooner or later. But yeah, that's a different topic. I could rant like hours on singletons, but I won't do that right now. Good, what is the real problem here? The problem is not only in singletons, but the problem is in every static dependency which you have in your code. And with static dependency, I don't only mean that you have a static method call or dependency on a static attribute in your code, but also using globals, using PHP functions which affect globals, using super globals, and all these things. What this code actually does, it is creates a dependency to a global state in your application. And one of the main purposes of doing object-oriented development is to avoid a global state in your application, but only have local states in single objects which are nicely encapsulated and which encapsulate and hide the complexity to somebody interacting with these objects. So this is the essential issue, that you are not capable of hiding the complexity anymore if you expose something to the global scope of your application. How can we easily fix that? Yeah, the idea should be clear by now, I think. there is a third parameter to our constructor, or if you prefer to use setter dependency injection, you get an additional setter which enables you to inject a logger into your weather loader, and then you simply call that log debug method on your logger and you're pretty much done. This allows you to easily replace the logger during test time. You can inject whatever a null logger stub which doesn't log at all if you don't care if this debug data is logged. Or you can inject a mock object which asserts that there is actually something logged, and so on. You have all the flexibility which all the nice testing frameworks out there give you in order to test these cases. What is the essence of that? I would really, really recommend to you to never use static access or global access in your application anywhere. If you're in the lucky situation that you have to start a project from scratch, please make it a rule to never use static access. If, which might be the more common case, you need to deal with legacy code, then you should really attempt to get rid of all your static accesses sooner or later using the methods of refactoring, and so make your code easier testable, but also way easier maintainable, because then you can replace stuff. Remember the logging thingy which we got right here. Imagine you have a logger which is implemented on basis of the file system, and then you need to scale out your application to run on multiple servers and have load balancing. Then logging to the file system is suddenly not an option anymore, but you want to have a dedicated log server or something like that report your log information there, use the syslogger and have that aggregated somewhere, or whatever other reason. So in our case, you would have to replace the current logger class and really replace it, refactor it, rewrite it in order to log to something else, which makes it really, really hard to test that stuff in a development environment, because, of course, on a developer machine, you don't have that fancy logging service in the back end which collects all your logging data, but you want to have it write to the file system, or even to run faster, write it only to memory. So what that results in that is you never want to have static access, but you always want to inject dependencies in the one or another way. Like, as I already said, you want to have either constructor dependency injection, or you want to have setter injection and use default instantiations maybe. And if this gets too complex to set up in your application, there might be the need for a dependency injection container which solves all these looking up of dependencies, injecting dependencies everywhere, and that gives a really, really neat and nice application. Good. I give you guys a couple of seconds to relax and to breathe. Maybe somebody would have a coffee, as I'm doing right now, because I know that having somebody talking that fast and talking on that stuff can really, really be hard, especially for the European-located people, which already have a full working day after them. Okay, more liquid life. After that, let's dig into the third issue of testing, which we can find in the refactoring of our weather loader example, which we just did. The weather loader is pretty fine, but of course there are other classes in there which can also contain code which is not easily testable. And I've created a little example for you, which is this weather service, which is capable of fetching weather information from a web service. And of course I wrote some testing issue into it so we can see where it is and what the essence of the issue is and how to craft the code better that it becomes more testable. What you see here is the simple weather service class, and the weather service class has a dependency here, which is an application registry. Something like that is really, really common in applications, like you register something in your app registry, a logger, for example, or in our case, an HTTP client. And when you need it, you just send the app registry to the needing object, and the needing object can go there, ask the app registry, oh, please give me the HTTP client, I want to use it. And after that, it takes the HTTP client, performs a GET request with a created URL, and you are done. This is really, really good object-oriented code from a first look at, because it's really, really slim. The weather service does not do anything which it is meant to. It's just, again, dispatches to some generic class which handles HTTP requests. that class might be really common in the application, or might be a class, an object from a framework or something like that. So it's really straightforward code. However, if you want to test that code, you will run into a certain problem. Let's look into some test code. This is a stripped down testing example on how to test this simple weather service class. You all might know this test method from the PHP unit framework. Otherwise, in most other test frameworks, it looks pretty similar how to realize such a unit test or integration test, however you will ask for it. So in order to test that, the straightforward way would be, of course, to create a mock for the HTTP client, because we don't want to have our test code execute actual HTTP requests, at least not the unit test code. There should be an integration test which makes sure that, yeah, Google is still online, which makes sure that the data retrieved from Google can still be retrieved under that URL and all these things. But if you go for a unit test, which would be really sensible for such a scenario, you want to have a mock object for your HTTP client, and yeah, that is the normal code which you would have. However, since we used our application registry, we still need to create a second mock, because yeah, we need an application registry since our weather server requires an application registry. What that means is that you need another mock from the app registry, and again you need to mock a method here which is also called get, and which will then return our HTTP client mock. So you can expect some more code here which allows the mock object to return that stuff. And after that we can instantiate our weather service with the app registry mock, and it will work fine. We can do some assertion on that. At a first glance, that might not look as a big issue, but if you use multiple such objects, like app registries or similar, in your application code, then it might really get a mess mocking all these objects. And on the other hand, we talked about earlier that code should be as easy readable as possible. This actually makes your code unreadable. Somebody looking at your test code in order to understand how the API of your application works, how to understand how the API of the weather service works, will be quite wondering what this app registry thing does here and why it's mocked here and so on. So yeah, it is a solution, it is a working solution for code which already exists in that way, but still it's not a really good solution for writing really testable code. Of course, the second solution would be to just use the application registry, or to write a testing application registry which you can use here. That makes your code, the test code, more intuitive, so everybody understands, oh yeah, he is creating an app registry here. Ah, now I also see how the app registry is used and how it's expected to be used with a weather service. Still, what you're doing here is using productive code in your tests. Like if this is the standard app registry and somebody needs to refactor that one, needs to change that one, your code gets a dependency on how the application registry is meant to be used, and not only from its get method, but also from its set method. Maybe also your app registries does some magic in the backend, like whatever, reading configuration files for their stuff and all these fancy things. You can never be sure that that won't happen. And if that occurs in your code, the app registry might actually slow down your test case. And as I said before, a fast-running unit test suite is a really important thing in your project, because if your test suite does not run fast, none of your developers will execute it anymore, and everything will be left to the continuous integration server if you are lucky to have one, right? So that is also a way of how you can handle such situation if the code already exists, but that is not a way when you want to craft code in a way that is easily testable. So it's also a no-no. Let's look into what the real issue in the code which we have seen earlier is. The real issue is that you are actually reaching through an object. Remember, you have that application registry, and normally you say that you should only act on the direct dependencies of your class, of your object. And what you do here is you ask the application registry for something and then act on the return value of that. And that is never a good idea if we are talking both of objects which execute real logic and are not only just stubs. So what would be the fix? the fix would be to not inject the application registry into the weather service thing, but instead inject the HTTP client itself and just use this HTTP client, which should be stored in a property or somehow. So again, skip code here, you realize that, of course. What that also gives you, if you inject all the objects which you really need in scope of a class, it gives you a nice indicator when you hit a certain border and it's time to refactor your code. Because if you think about, there might be 1 parameter to the constructor, there might be 2 parameters to the constructor, even 3, 4, or maybe even 5, where your actual border is depends on you and your project. But in the end, if you see like 10 or 15 objects being injected to the constructor, you have a really clear indicator that you need to refactor your code and put maybe another abstraction into it, because there is too much dependency hassle here in the weather service. So if you only have your application registry, nobody can see from the outside or from a first glance at your code if there are too many dependencies used. Think about, in your application registry, there's also the mail service object, or whatever you use in order to send mail. And if you give the application registry here, it's easily possible for example, a junior developer to think, oh, we need to send out mail when we fetch some weather. Oh, that's easily possible. We just put it into the weather service. And then, again, you get a problem with the responsibilities of your class, and you get an even more heavy problem with writing your tests. So the essence of looking into this issue and seeing how to do it correctly is that you should never actually pull dependencies from somewhere. There are these patterns like registry, singleton, or service locator, which are really, really on vogue nowadays. Everybody wants to use a service locator. But in the end, if you pull dependencies, this harms you in terms of writing your tests, because you need to mock or use the class or the object which you pull the dependency from. And it also harms your code, because some code smells will be hidden from you and you will never ever find them. So the basic idea is to not pull dependencies, but to push them explicitly. And on the other hand, don't reach through objects. That is what we have seen with our application registry. We have not just interacted with the dependency of the application registry, but we have asked the application registry to give us an object which is only visible from the outside because it's internal and we know that it's there. And by this, we have reached through the application registry in order to grab the HTTP client. That might not be a big issue if you do that with the application registry, but if you do that with other classes, like asking some whatever gateway to give you his database connection, then you really run into trouble. Good. We have the 4th issue left to investigate. And let's just go over and look into that. As I promised, I have quite some slides here. Of course, I built another issue for testing into the logger class, which we did not see yet. So the logger class simply receives a file name in the constructor. It then does some error checks, like looking if the file which is given as a log file is readable. Then it does some fopen on it in order to append new log messages. And then you have this log debug method, which does nothing more than just writing down out some information into the file handle using the message and the data retrieved. Again, it is a class which looks really, really straightforward. It is really, really simply crafted. But still, there are some problems with testing that. Of course, the first idea on how to test that, again, we see some test code here, is to write this log debug success method. Of course, you also want to have failure checks there. And what we now need is a temporary file name which resides on our hard disk and which can be used in scope of our unit test to test that the logger actually logs to disk. And there is this getTempNum functionality in PHP, but still, if you want to have a clean unit test suite, you want to make up a dedicated directory which is located somehow close to the unit test suite. You want to create that inside there. You want to create maybe a dedicated directory for your test case and all that things. So therefore, I snip that code here and put it into a private or protected method, which can simply be called. But if you did that once or twice in a project, you might know that there can still be some hassle involved in creating these files, especially if you want your code to run on different operating systems and so on. If we now have such a temporary file name which we can use for the logger, we of course only instantiate the logger with it and perform the logd work, and after that we can of course read the file again and assert that the logger wrote something into that file. Remember what I told you up front, that test suits, especially unit test suits, should run as fast as possible. If you start testing against the file system, there's a clear indicator that your test suite will get slow. The same applies, of course, to writing and reading from a database, to talking to external services, using whatever stuff in the system. And what you also need to do is you need to unlink the file from disk if the test was successful. But again, this will result in often test files if your test fails, like the file will stay on disk. And if nobody cleans it up later on, then it might result in the end in your disk running full from log files from your test cases. There is of course a solution for that, but the first thing to note is no, you don't want to have such test cases. You don't want to have classes which execute some kind of logic and have them write to the file system or use an external service in your unit tests. That is a rule that you want to follow. No file access in unit tests. Maintaining temporary files sucks. Creating them, you need to create temporary file names. You need to clean them up. You need to deal with system differences, and you don't want to do that all over your code. So there is a solution for that, which is called VFS Stream. VFS Stream is a pair package. You can Google for that, and there's only one PHP package in the world which is named like that, at least I expect. So you can really find that easily. The VFS Stream helper class allows you to set up a virtual file system, that is what VFS actually stands for, in your memory, which looks to the PHP Streams API as if it was a real file system. You might know that there is, since some PHP versions, a Streams API, which is used by all these fopen and also file get contents functions. So you can hook into that, define your own URL scheme, and have your own class, your own code deal with the file system calls coming out of the Streams API. So somebody thought, yeah, great, we need to test file system access, so we create this virtual file system. Since PHP only allows you to use classes and not objects for that, we need to use this ugly static code. And what it actually does, it creates a brand new empty file system called test in memory. We can then ask the VFS stream to create a URL in that file system. So it creates all the fancy prepending stuff, a string for us, which identifies that file system. And then we just append the message log file name here in order to create a log file path. And then we run our test again. What we could do here is, of course, assert that this virtual file system got a new child. We want to make sure that the message log is actually created, and after that we have our assertion again. Since VFS stream will recreate the file system on every call to setup, we can simply skip the cleanup work. So this makes it really, really easy for us to test these file system accesses in our logger class. But still we are bound to the issue that nobody will understand this test code if he first jumps into it. If you have a new developer in your team and you tell him, okay, come on, just look at the test code, you can easily spot how stuff is used and how stuff is expected to work. Use the test code as your API, then you're doomed if he stumbles over that, because he needs to dig into that and know how it works. And if that happens a lot in your source code, like having a lot of file system dependencies, then he will take quite some time in order to investigate it. And it's not really easily spottable if you got a bug in your logger where the bug is. Is it a problem in the VFS stream? Is it a problem in how we wrote up the test code here because it's quite long? Or is it just a problem in our logger itself? So this is an option if you already have code which works with file system accesses, but it's not an option if we want to craft testable code from scratch. So yeah, it works, but I ranted quite a lot about it. It's not really a good solution. It's not really the solution which you desire. Instead, what the problem here is that you have a hard system dependency in a class which executes logic and which might be used often in your application. And if you have a lot of these hard system dependencies in your logic classes, then your tests get slow, your tests get messy, and so on. So what you want to avoid as much as possible is these hard system dependencies. How can we do that in our example? Of course, the answer is pretty simple. Introducing a very, very, very slim and thin class which encapsulates the file system access for you, like something called a file handler. This file handler will also already have the log file class in itself, and then the logger only uses this file handler thingy. What that results in is that we can easily mock out the file handler when testing the logger, and we have a class which we can use in any other case where file system access is required. We can just put the file handler in there. We can skip lots of duplicate code for checking if a file already exists, if a file is writable, and so on. All that stuff can be encapsulated there, and then we have only one really, really tiny, really small test case in our project which needs to deal with the actual dependency to our system. Of course, the same thing applies to all other cases where we have system dependencies, like you saw that already with the HTTP client. We could, of course, have realized HTTP access right by using the file system wrappers. Using an HTTP URL to fetch data from HTTP is pretty fine. Or by using curl, which also provides us with a nice interface. But no, we put it in a dedicated, really slim abstraction, the HTTP client, in order to mock it away wherever we have to use that in our application, so we can easily replace and easily test it. Good. What is the essence? You should abstract system dependencies by any means. Whenever you have to interact with your system directly, please make sure to find an abstraction. And of course, this abstraction should be as low and as thin as possible. Even if it's just one class which implements the same interface as PHP provides for you, you can just write that class, dispatch the stuff. This single call, which is intercepted into the instead of using the real PHP interface, does not really harm your application. Stuff like database access harms it way more in terms of performance. But if you do that, you can way more easier test all your code. So that was a lot of ranting on code, and I hope you got really good impressions on 4 of the biggest issues when writing code, how to test it, and how you can craft your code in a way which is way easier to test. Let's come to a little conclusion out of that. What we have seen in the past hour or so is the single responsibility principle, which is one of the fundamental principles of object-oriented software design. And as you have seen in the first issue, it is really sensible in terms of testing, because if you keep to it, if you stick to it, then testing gets way easier and way more convenient. The second thing which we saw was the open-close principle. What the open-close principle, also one of the fundamental principles of object-oriented software design, tells you is that you should keep your code open for extensions, like by replacing objects with other objects, but keep it closed for changes. Remember the single access and the static access. If you want something to log into a different log file, you would have to replace the static call. So open-close principle helps you to craft easier testable code. We saw the law of Demeter, which is also quite commonly known in the world of object-oriented design, which tells you you should never reach through objects. And we saw the issue number 3, which was a clear violation of the law of Demeter, and that resulted in difficult to test code. And after that, we saw the dependency inversion principle, which states that your code should not depend on system details, but depend on abstractions. So what we've seen in our webinar today is essentially that testable code and object-oriented design, or good object-oriented design, are really, really closely related, and that both help you to write better code. If you want to write your code testable, one of the biggest issues is that you need a good object-oriented design and nicely crafted classes in your system. And of course, you desire to have good object-oriented design. And to achieve that, a good way is to think about the code that it should be testable in the end, to think about the interfaces that they should be testable in the end. Those both are really closely related to each other. I hope that is a nice conclusion for you, and of course we now have time for questions, comments, feedback, but before we go there, I want to say thank you for listening. If you want to stay in touch with me, please don't hesitate to contact me. Here's my email address, my Twitter nick, the Twitter nick of my company. You will find the slides online, hopefully right now, if my colleague already put it online. It is on talks.quafu.com. You can find them there for review. And if you want to rent a PHP quality expert, please don't hesitate to visit our website and get in touch with us. Thanks for listening, and now I'm giving over to Lydia.
Okay, thank you so much, Toby, for this great webinar. Let's have a look into the Q&A window. I hope the clicking sound is not disturbing too many people. For those who have questions, please do not put them into the chat window. Please do put them now into the Q&A window on the bottom right. It's just easier for us to read and answer them there. And there's just the very first question that I can see. How can you test closures or anonymous functions, perhaps using a delegated method in a class?
Oh, yeah. This new fancy stuff about anonymous functions and closures in PHP, which people are attempting to use. If you are using a closure inside your object and you defined it inside your object, it's basically the same as for a protected or private method. What you put into the closure should actually be seen as inline code and should be tested by the public interface of the object which uses the closure. For example, if you use a closure in order to sort an array, that is just inherent that you test the sorting of your array by testing the public API, like the array is returned or something, and then you need an assertion which makes sure the array is sorted. If you throw around closures, if I may phrase it like that, of course you can try to test a closure in a dedicated test case. Like if you put it, create it outside of your code and then put it into your code, you can test the closure in itself, and you can test create a test closure like a mock object, similar to a mocked object, and send that to your object. But I should warn you, at least to some degree, using closures in PHP is not intuitive to all developers. So make sure that you really know that all of your developers know how to work fluently and to read closures fluently, and that they are not getting what the fuck in the face if they see a closure in your code. So in the end, if you want to make sure that your team can easily grow, I would try to avoid closures and instead use dedicated objects, dedicated methods, dedicated classes instead of using a closure. Of course, that makes more effort in creating that stuff from scratch, but in the end, it is way more readable if you go that way. I hope that answered the question.
I'm sure it does. Thank you so much. As we have already as the 1 hour we had is already gone, let's pick just one more question. And for those whose questions we couldn't answer now, I'm sure that Toby will be happy to answer them if you drop him an email. So let's see. Oh, here's one. On which situations is it a good choice to use mock objects?
That is a pretty nasty question, because there is no straightforward answer to that. No problem, no problem. It is a really interesting question because that is one of the problems which we often have at our clients and which we help them to solve. Because most people nowadays heard all that unit testing stuff is so great, so they want to have everything unit tested. And then they come to a stage where they actually write the same code they have already written or they will write after creating a test, which they write again with mock objects. Like, oh yeah, remember this weather loader example, if it got more objects and if it got some more complex code, what you would do in your tests is recraft the full process flow of that class within your test case, and that is not a good thing because it's error prone. You need to refactor that often because it has so many dependencies and it sucks. So you should use mock objects only for real unit tests, and that means, in my experience by now, that you should use it for the lowest level modules in your application. For example, the weather loading thingy which we add here is might be a pretty low-level module for your application because it's used pretty often in higher-level things like your controllers or your model or something like that. And if it's used often, you should make sure that everything works fine in there, and then you should use mock objects. If you are on a higher level, for example in controllers, I would typically not recommend you to use unit testing there, especially not if you are in a very agile project and your stuff changes a lot. There you should better go for like a system test, an automated acceptance test, and so on, and make sure that the whole stack works together. So mock objects are really a thing which you should use for unit tests or some special kinds of integration tests to mock out very low-level functionality, but otherwise they can really create hassle in your test code. Thank you all together. It was a pleasure to be here, and I hope to be here next time. Thanks. Have a great day.